important here. So if you use a very unsophisticated random number generator, one with like a very low mode or something, these sort of approaches can fail, and they can fail in ways that are hard to detect. But the good news for us in Python is that we have a built-in random number generator based on some pretty sophisticated methods. As well, the same random number generator is also built into NumPy. And for all intents and purposes, you can treat the Python random module as producing real random numbers. But as hackers, you all know the difference between pseudorandom and random number generators. So you can keep that in mind as you're answering these sorts of questions.
Jake, thank you very much for that excellent presentation. I am also a budding statistician, and I know it's not the right Python function call. I think it's a gamut distribution, I'm not sure. But where you can say the gamut distribution, where you can specify the mean and the standard deviation of your sample set, and it can create however much you want. Is there a reason why you didn't use that for generating more sample data in your examples here?
Yeah. So I guess the question is, if you know your data is coming from a gamma distribution or a normal distribution, that's completely valid. But the normal distribution is only really, in most cases, is only really an approximation. So if you use, say, a normal distribution, you generate more data from that distribution, what you're learning about is the normal distribution that you've assumed fits your data. And what we want to do in these methods is we want to not make those assumptions about what the distribution is, but rather kind of let the data speak for themselves in terms of the distribution. And that's why we don't do these things. So it's a great solution if you actually know that your data is normally distributed with a certain mean and a certain standard deviation.
Thank you very much.
Yeah.
Just wanted to confirm on the example where you had the points plotted and you split into two graphs. Did you just randomly pick the values, like depending on which graph is going to go on, they were random?
Yeah. So that's the key to this cross-validation is that it's a random split.
Okay.
Especially, you might have a data process that's kind of biased where the first half is slightly different than the second half, and then if you do a split down the middle, you'd run into problems. So for packages like scikit-learn, they'll automatically do the right kind of random split to make sure that you're getting the right answer on your data.
Thank you.
Yep. Let's do one last question.
Sure. When you talk about cross-validation and it's not a good idea for smaller, like if you only have 20 points or something like that, what do you do when you
Yeah, that's a good question.
You don't have a ton of points. You still don't want to overfit, or
there are a couple things.
If you can just give me words, I can look up on the
Yeah,
internet.
there are a couple things you can do. So one, you could do something like a leave one out validation. So rather than splitting your data in two, you just hold out one data point and you fit it on the other 9 and then ask how well it fits that one. So that gets you a little closer to having the full data set.
Yeah.
But I think the broader answer is that if you're doing machine learning on 10 data points, you have bigger problems.
Sure. Okay, thanks.
Yeah. Well, let's all thank Jake for his great talk.
You should take the time to go and check it out and maybe change what you're doing. So I'm going to talk a little bit about some libraries. I'm going to flip over to the notebook and do a demo. I'm not going to say what Jupyter is, because probably everyone in this room knows, and if you don't, you'll see it. I'm not going to say what Pandas is, because ditto. I will just say that Jupyter is probably a driver of some of the interactivity we're seeing in libraries these days, because so many of us now do our data exploration in the browser. Okay, so here's the dataset I'm going to use as a demo. This is the National Electronic Injury Surveillance System. It's got some fields that are not listed here, but here are the fields I'm going to actually use. So this is a Pandas data frame, or a spreadsheet if you like. Every row is an incident, an injury incident, and these incidents get reported. What product was involved in the injury is kind of the point of the database. So you can see we've got the age of the patient, their sex, the date it happened on, the product. So there's the floor, there's basketball, there's ceilings and walls, where it happened, what body part was injured. And the nice thing about this one, this is kind of why I chose it, is that for most of the incidents we have a little narrative, and that's nice for demonstrating some visualization features. So 17-year-old complains of hand pain after punching a wall in anger. Right? You can't plot that stuff, but if you have interactive visualization, you can explore it. So just real quickly, Matplotlib, I'm sure everyone knows that Matplotlib is the oldest plotting library in Python, really. It's been going a long time. It's still going strong, but usually now it's underpinning something else. Its original API was invented to mimic MATLAB, because it helps people to switch over, which is probably not the interface we would want now. It does have an object-oriented API. Sometimes it's hard to find in the documentation how to do things one way versus the other way. It's very powerful. You can kind of do almost anything you want in Matplotlib, but sometimes it takes some effort. And it's probably worth mentioning that Matplotlib 2.0 came out this year, and Matplotlib is now a lot prettier by default. So it's updated fonts, the color schemes, it's colorblind friendly, it doesn't have black lines around shapes by default, all that sort of stuff. Self-sample slightly, but I'll give most of the points. I need to make a whole of these data sets, and I've got k-gems. K-gems are the things I want to look up my data by. I might want to slice it on them or facet into different plots based on these variables, or color the points differently based on these variables. So I put in sex, what is the product, and what is the body part. That's my variables that I want to go and look up. Medians are the variables that I want to plot as functions of these other things. That's the rough idea. And so I put in age and day and incident count and narrative. Once you've made your data set, it's got, you can kind of look at what's inside it, right? It's got all these things. You can see the data that originally made it and all its parameters. But if you want to render something, here I'm plot. So first I just spin out away some of the variables because I want to make a simple plot first. So just keep these dimensions. And I'm saying make a scatter plot of day against age, which is what we did before. And the first thing you'll see is there's a widget here. And that one of my dimensions was product. And I didn't tell HoloViews what to do with that dimension. And I didn't use it in my plot. So HoloViews automatically turns it into a widget that I can select from. So every paging is here to look up your data in some form or other. Either it's inside the plot or it's a widget to go over your plots. So here I could switch between basketballs and doors. This was day against age, right? So we saw that basketball injuries fall off over Christmas. I noticed when I was exploring this that knife injuries seem to spike over Christmas. I assume people are preparing food, right? Stairs and steps. So you can see there's a kind of different age distribution for these things, and in some cases a different age distribution. So I'm going to repeat this, but this time I'll keep all my variables. I went through some of the way I won't simplify it so much. And here I've used overlay sex. So overlay means I want to see male and female on the same plot, and both of them will be different colours. Okay? I'm slightly nervous every time I hit execute because if we have a Wi-Fi issue or something, it's all JavaScript based. It's thinking. Okay, so I can throw away the variables, so we've got both product and body part are left over, and so they've both been turned into drop-down widgets. If they were numerical variables, they'd be sliders, but because they're categorical variables, they're drop-down lists. So now we could ask, for instance, I should point out, I also said in the specification of how to present this plot, I said turn on the bokeh hover tool. I said render using the bokeh backend and provide your. So now I can say, how are all these people using the wall to injure their hand? This one's punching the wall. This one's punching the wall. Punching the wall. It's fairly young people who seem to punch the wall, or at least, not younger than middle-aged people, both genders. But you can see it's nice, right? There were very few lines of code involved in this. There's basically one line of code. And I can ask questions like, when people are using their hand with the wall, what are the narratives? And I can explore it interactively. So I'll show you one more feature of HoloViews, and I'll stop. There are more features. Here, if you look at when I actually put it, I said bars plus scatter. That means I made an element called bars, an element called scatter, just put them next to each other. And when I'm making this bar plot is I want to say, well, when I'm up here, when I look at, say, how are people injuring their eyeball with the wall, there's not many points, right? So I would like to know for the products I'm looking at, what parts of the body are people injuring with their products, which of these drop-down lists are interesting, which ones should I bother to select? So I've made a bar plot to say, aggregate over all the other variables, and just show me how many people get injured on each body part for the product I happen to be looking at now. And I won't go through the syntax. Plus, you can see just put this together. It still gives me the variables that I haven't used. In this case, the body part is not used in this one, so when I change the body part, the left-hand graph won't change, but the right-hand one will. Right? On the left-hand one here, I can see that for basketball, it's usually ankles, fingers, a bit of head and knee, right, that's getting injured. And so I could choose that, and then I could go over to say how are people injuring their ankles when playing basketball. We're nearly at time, so I'm going to stop showing you things. There's other nice features of HoloViews, I guess. The take-home thing is, the syntax is different to stuff you may be used to, but it is very concise. Like I said out my data set, and I can do all these things really well. So if I can Tennessee talk what would be good in a data hackathon, this would be excellent. So long as you already know what you wouldn't be learning this in a data hackathon, that would be great for exploring your data. Alright, so let's go back. So, I've got 5 minutes. I'll use those 5 minutes. First thing to say this. I think that this may be what people really want. And it's a scary slide to write because it's very personal, right? And everyone's a bit different. So these are just my suggested starting points. If you want to produce static publication quality graphs, I would recommend Seaborn. If you want to get started with interactive plots and you don't want a huge learning curve, then I think bokeh and Foley are both really nice. They have slightly different strengths and weaknesses. Alternate is fairly young and its documentation is fairly young, but I think it's going to be really interesting. I didn't talk about it much, first because it's young, and secondly because Jake Vanderplas is involved in that project. Talked about it fairly extensively in May, so you can go and watch his talk and hear all about it. I think Plotly has the feature which may be positive or negative, and it has this business model, which may be a good thing depending on what area you're working in. HoloViews and bokeh is really good for interactive data exploration. I didn't talk about it, but there's been a lot of talk about Data Shader recently as a way of handling really large volumes of data when you've got like millions or maybe billions of points. You can't just plot those on a graph because the performance and also over plotting, right? Once your plot points get to a certain density, you can't see how many there are anymore. So you need something that works out appropriate binning or density rendering of your plot and send pixels to the browser, not the points. And Data Shader is one of the things that does that. Another is, I don't know how to pronounce it, AS. And I've got to say that as we get to the bottom of the graph, these are less things that I have personal experience in and more things that I hear people talking about. I don't really work with geographical data myself, but people talk to me about like my leaflets. So actually after this in the questions, if people have particular recommendations, especially for those couple of things, maybe you could share them. And this very last thing, this is really interesting, I just didn't have time to fit it in. There's a few things that let you build your own dashboard or your own web app that explores data, where the front end talks to the back end and it's pretty much a chat, but it's very easy to write. Plotly Dash is one that came out not too long ago and people really like it. Bokeh Server fills a similar niche. BQplot, I wish I had more time to talk about BQplot. It works closely with IPy widgets, which are the Jupyter Notebook's preferred way of doing widgets, so sliders and drop-down lists and things. Putting a BQplot together with widgets and wiring them up is a nice way to get at that plot as well, and it's probably the most notebook native way to do it, right? It's not a standalone web app, it's in the notebook. So, I guess, how long have I got? I managed to rush through things slightly faster than I thought, so I'm going to go back and say, this is one I didn't get to talk about, probably. It's been a transparent way so that you can see the specification and modify it, and it's a declarative object. And it does do that. It was originally something very much based around online use, but they've now kind of fully open sourced the JavaScript library. You can use everything offline. I think there may still be some restrictions on unpaid accounts, possibly exporting to certain file formats. And it's cross-platform. So it's quite nice to get things done quickly, and it has the chart types if you want. It probably doesn't give you as much low-level performance bokeh, that's my feeling. BQ Plot, I was just talking about, it's very interesting. It's much more lightweight than say bokeh. It's probably not intended for huge quantities of data. Alright, I have to stop. But it's not intended to do everything. It's intended to work with like language and some other libraries to accomplish what it accomplishes. Okay, so I think we've run out of time, so I'm just going to say, what have we learned? Don't have to. Okay, questions? Yeah.
SQL Alchemy ORM is a very popular one. If you want to do non-relational databases with MongoDB, you can use Mongo Engine. There's a smaller framework called Pewee that's been getting some attention lately. So the idea is that Flask is very, very minimalist. It has almost nothing in there. It has only the bare necessities for what you need in order to do a simple static website, essentially. It includes templating, URL routing, error handling, and a debugger. That is all. However, it is designed to be incredibly extensible, so you can plug and play and choose which components that you want to plug into your website and make it work exactly the way that you want. So let me give you an example that shows you how you might do data modeling using SQL Alchemy and Flask. So there's an extension called Flask SQL Alchemy, which is designed to cleanly integrate these two different modules. So you would just install that, and that installs SQL Alchemy itself as a dependency. And then you do some basic setup to configure it. So I'm going to import that extension, and I'm going to configure it onto my Flask application. And as you can see, the Flask application also has this .config object where you can set information that your application or extensions can read and use. So in this case, I might say that I want my database to be a SQLite database that uses the test.dd file under the temp directory, whatever. The thing that's really important here is that you notice that you're importing the SQL Alchemy class, and you're creating a variable called DB that you get by wrapping your application with SQL Alchemy. So now that you have this DB object, you can do some very familiar things with it. So here I'm defining a data model, a blog post data model. And you can see that it looks very familiar to the same sort of thing that you would do with the Django ORM. In fact, I'll take the previous example and I'll put it on the same slide so that you can compare and contrast. They're not identical, but they're very similar to each other. And if you've used the Django ORM, you can use SQL Alchemy in almost the same way. You can also manipulate data in very similar fashions. So you can create an instance of the blog post, class, assign information to it, and then instead of calling .save on it, you have to add it to the database session and commit to the session. It's the same basic concept. SQL Alchemy is just making you sort of be a little bit more explicit with how this database interaction works. And you can query data in the same way. So you do .query instead of .objects, and you can do .filter or .filter by, and there's a lot of the same basic things that you can do in Django, and you can do the same sort of thing in SQL Alchemy. In fact, I'm of the opinion that SQL Alchemy is a more powerful object relational mapper than Django ORM, but that's another topic for another time. So to talk about data models here on a higher level, Django's data models are easier to get started because they're built in. So you don't need to import and install anything else to get started. However, Flask allows you more flexibility to choose whatever you want to use. Django assumes that you're going to use a relational database. Flask, you can use whatever you want. You can use Mongo, you can use Google App Engine's data store, you can use whatever, it doesn't matter. But of course, the more options you have, the more flexibility you have, the more chance you have to screw something up. So, it's a trade-off there. Let's keep going. Most web applications have users, and they also have an admin to be able to view information in your database and modify it. So how do these compare? Can you do this sort of thing with Flask? Well, with Django, we have your familiar Django.contrib.auth. It's built in, it's easy, I'm sure you're all rather familiar with it. If you need extra information for users, you can swap out the user model. It's a little complicated. You can also make a user profile to attach to it. That's also a little complicated, but it works pretty well. With the admin, you have Django.contrib.admin, also built in easy, very customizable, and there's a lot of documentation out there with a fine-grained permission system so that different admin users can get access to different objects to administer. So how do we do it in Flask? Well, as you might imagine, you don't have users built in because you don't even have a data model built in. But there is a very popular Flask extension called Flask Login, which is generic and works with just about any data model, including SQL Alchemy if you like. So here's an example of how we might do that. I'm going to define a user class, and you can see I'm importing this user mixin from Flask Login that gives it a couple of extra little superpowers so that we have some standard usage that you can use across your framework, regardless of whether you're using SQL Alchemy or Mongo or whatever. So for example, in my route, I might say if current user is anonymous. Now current user is something that's provided by Flask Login. It's a pointer basically to whatever user is currently logged in. And the is anonymous thing is provided by that user mixin that I showed you earlier. So here's a simple view where I'm saying if you're anonymous, just run to the splash page, otherwise show the user home page. Flask Login will also give you a login required decorator, which you've probably seen from Django as well. So it's just a decorator that you apply to your view. If the user tries to access the view and they're not logged in, they'll get a 403 forbidden exception. Again, very similar to Django, but the idea is that you build this piece by piece. With user permissions, you can also use the Flask principal extension that has a very similar fine-grained permission system, the same way that Django contrib.auth models do. So the idea is if you don't want a permission system, you don't need to have it. Django users have that built in by default, and you have to sort of deal with it whether you want it or not. With Flask, you can decide if you want to have that in or not. And with the admin, as you might expect, there's a Flask admin extension as well. So you want to use that, you install it, you set it up, and you decide which theme you want to use. It has a couple of themes built in based on Bootstrap, so you can write your own. It works with several different database backends, including SQL Alchemy and Mongo and Pewee, and it's designed to work with or without any sort of any user extension that you want. So it's very common to have a local Flask login and Flask principal, but it's not required. Here's some screenshots of how it looks. Here's the list view, so you can see all your users. Here's how you edit a user. As you can see, it's all standard Bootstrap. So it's pretty familiar and it's pretty powerful. Now, there's a lot of different extensions that I've just gone over, and having a user and admin system is pretty standard. So there's actually an extension called Flask Security, which all it does is it takes about 5 or 6 different Flask extensions and bundles them all together into one package so that they're already designed to hook up together properly. So you can just install this one extension, and bam, you've got your users, your permissions, your admin, it's all there, it's great. And of course, it works with SQL Alchemy, Mongo Engine, or Pewee, so you've got a lot of flexibility here. So again, Django has a user framework and admin built in, and they work very well. They're not as flexible and perfect as I would like, but for a lot of people, they work great. Flask requires a lot of different extensions working together in concert, which makes it nice setup in such a way that you can understand every single piece of the puzzle of how it's put together. So, Django versus Flask when it comes to APIs. Django REST Framework is amazing. I really wish that Flask had something that was as well put together and as clean and as abstracted as Django REST Framework. We don't have that yet. Maybe someone will put that together the same way that people did that for Flask security. But as it is, you can still use all the extensions that you want to put together something just as powerful as DRF, if not more so. And you have more flexibility as well, because you're not constrained to the constraints that Django puts upon you. You can use a non-relational database if you want to. You can use any sort of different components that you want to mix into your application to make it taste exactly the way that you want. So the question you might be asking yourself is, which one do I choose? And of course, it's up to you. It depends on the project. So let me give you a couple of brief bullet points so that you have an idea of which to go for. You generally want to choose Django when you're happy with all the choices that Django makes for you. So I've been talking about how Django restricts you to using a relational database. Maybe you like using a relational database. If that's the case, go for it. Django makes you use Django templates, although that's changed recently. You can talk about different templating systems. But generally, you want to go with the things that Django provides for you. The more that you do that, the happier you'll be. If you're not doing anything too unusual, Django will work great for you, because the more that you try to fight the framework, the more pain you'll experience. And also, Django sort of sets up a whole bunch of different things for you. You can keep that under covers, and you can learn how the ORM works and how the templating system works and how all the different pieces fit together, but you don't necessarily have to. By contrast, you might want to choose Flask when you disagree with one of Django's choices and you want to do things differently. If you want to use SQL instead of the Django ORM, for example. Or if you have unusual requirements, like using a non-relational database, or doing something else that seems a little bit odd or unusual for a web framework. Django will take you over the list. So I'm going to say, yeah, Django great. Or it's great to use Flask when you're doing a hobbyist side project, and maybe you're less concerned with having a working project and more concerned with understanding all the different layers and how they work together. It's great for really making you learn how the pieces fit together, and it'll make you a better programmer by having that understanding. So I'm about out of time, but that's all I have to say. Does anyone have any questions? I'm going to have a little bit of time to take questions, and I will also say I'm sure there are people here with a lot of opinions, so I'm going to be out in the lobby to have some argument session after this talk.
with messages. Very likely there's going to be more activity on the messages side than in the user side, right? You're going to have a bunch of regular users that are already registered and they're going to be chatting, so they're going to be sending a lot of messages. So if you find that you need to scale your application, you're going to be scaling the whole service. So you're going to have the necessary number of instances to satisfy the load for the messages, but then you're going to also be having a lot of instances that can deal with users that are not there. You're going to be overscaling for the user side, and there's no way to have more fine control. The control is basically the server versus the main service. Also consider the case where, let's say this is an old application, you did it in Python 2, and now you are interested in going to Python 3, and that's going to be probably going to give you a headache, right? Because it's all or nothing. You're going to have to upgrade the whole application in one go. So all of these are problems that are typical of what we call monoliths. So these big applications that are built with a single code base. Now, this is also a real application. It's the same application. It's also on my GitHub. It's converted to this idea of microservices. And you can probably guess that it is basically to write smaller services, and the services then talk among themselves to achieve the whole function of the application. And in this case, you can see we went from 2 green boxes to 5, and Celery is not there anymore. So we have 5 services. You can see in the bottom, you can see the client UI. So this is a service that serves the application that runs in the browser. For this particular case, I wrote that in Python. In most cases, I'm going to guess that this is going to be a Node application, and that's totally fine because they're independent services. You can write each service with the best technology for that service. So we have a client UI, we have a service that deals with tokens, that basically this is authentication, messages and users are separate services, and then we have the Socket IO service, which is the WebSocket push notification module. So they're all separate. In this case, these are all Flask applications. Some of these are so small that you can open them in your screen and see the whole code. And the ones that you don't open into screens, not more than that. They're all very small. You can see that we went from 2 orange boxes. We had a database and a message queue on the monolithic case. Now we have 4 boxes. We still have the message queue that serves the same function. It helps these services communicate among themselves. But then we have 3 databases. We have a database for the messages service, database for the user service, and a database for the token service, which stores logged tokens. And then what else we have? We have a new box, a blue box called service registry. I'm going to talk about that more later, but basically this is a very efficient database that keeps track of all the services that are running. It knows what's running, and then it communicates with the load balancer, so the load balancer knows what the services are. Now, these 5 green boxes, they're all independently scalable now. So now if I have more nodes on the messages side, I can run more instances of messages and then keep users at 1 or 2, for example. So I talk about disadvantages of the monolith, and all of those now translate into benefits when we're doing microservices. The complexity is greatly reduced. Each service, as I said, it's a very small Flask application. Reminiscing of the Hello World type application you see in the implementation. They're actually very simple to code, very simple to maintain. Because we're forced to keep things separate, it's less likely that we're going to introduce bugs due to coupling. The user service has no way to access, for example, the messages database directly. It needs to talk to the messages service. So messages will have a bucket